everyone, welcome to Byju's classes. Rather I should say Aakash Byju's classes basically. And I am Rakhi, your mentor for this particular session. A very heartwarming welcome to all of you guys over here for this particular session on Aakash Byju's JEE platform. So everyone, just let me know if I'm audible and visible to you. Just say me hello ma'am, hi ma'am, or the thumbs up signs so that I can actually have a green signal that everything is fine over here now. So guys, where are you all? Just let me know. Hi Aryan, is there any voice? No voice? Hi Aditya. Hello. So am I audible and visible? Just let me know. Hi Mr. Ashraf. Good afternoon. Hi Sampath. Good afternoon. Welcome to the class. Hi Aakash Kumar. Good afternoon. Welcome to the class. Okay, fine. Cool. Okay, fine. Hello Pavitran. Hello Rohit Kumar. Good afternoon. Good afternoon everyone. A very warm welcome to this particular session. I'll say it's yet another wonderful session I'm going to take up for physical chemistry just to enhance your preparation for coming JEE exams. And over here we'll be discussing, I will be actually discussing that what actually I'm going to discuss? I am going to discuss the most important questions of physical chemistry. Yes, Mr. Sampath Kumar, the session is going to help you a lot. Hi Shravan, good afternoon, welcome to the session. So dear ones, just fasten up your seat belts and come along with me to actually go for the journey of solving the questions in physical chemistry. Hi Ayushman, good afternoon. Hi Ambuj, good afternoon. Welcome to the class. Fine. So before I move ahead, let me just tell you one thing, that you need to subscribe the channel for the further notifications of the classes which are going to actually take place over here on Aakash Byju's JEE platform. Well, I'll just say one thing, that if you actually like this session, please hit the like button and do share this particular session right now at this very moment among your all the friends, your peer groups, so that they can also boost up their preparation for the coming JEE Mains 2022. Okay dear ones, here I go without actually delaying a minute now. And yes, we are with the very first question in front of you. Okay, so Namaste Rajiv ji, good afternoon, welcome to the class, enjoy the session, and here is the very first question. The question is in front of you. Come on. So, a 10 milligrams effervescence tablet containing sodium bicarbonate and an oxalic acid releases 0.25 ml of carbon dioxide at a T temperature equals to 298.15 Kelvin, and P is equals to, that means the pressure is equals to 1 bar. If molar volume of carbon dioxide is 25 liters, under such condition, what is the percentage? What is the percentage of sodium bicarbonate in each tablet? Mr. Ambud, just please solve the question and then let me know the answer. ऐसे ही direct randomly answer मत कीजिएगा. कुछ भी answer मत कीजिएगा. पहले solve कीजिए and then tell me the right answer. Is it 16.8 or 8.4 or 0.84 or you can say 33.6? Okay, so what is the percentage of sodium bicarbonate in each tablet? Come on, Sampath says that ma'am it's option number C. Okay, fine. So let me tell you and let's move on the solution part now. So we have been given with the weight of the tablet, which is 10 milligrams. Okay, we have been given with the volume of carbon dioxide release, which is 0.25 ml. Temperature, pressure has been given to us. Molar volume of carbon dioxide has been given to us. We need to talk about the percentage of NaHCO3. Here we have been given with the molar mass of sodium bicarbonate, which is 84 grams per mole. So what should we do? We will be calculating first of all what? Not calculating, let me actually write the equation for you. It's twice of NaHCO3 plus H2C2O4, which is oxalic acid, giving us Na2 C2O4, Na2C2O4 plus twice of CO2 plus twice of H2O, isn't it? Yes, of course. Now, from the stoichiometry of the reaction, we can say one thing, that 2 moles of sodium bicarbonate gives us the 2 moles of carbon dioxide, which means by unitary method, we can say 1 mole of sodium bicarbonate is going to give us the 1 mole of carbon dioxide. Just note it down in your notebooks, because I believe that you are actually having pen and paper along with you. Talking about the calculation of moles of CO2 released, if I just talk about moles of CO2 released, moles of CO2 released. So I have been given with the molar volume of carbon dioxide, which is 25 liters. I have been also given with the volume of carbon dioxide that is released, which is 0.25 ml. So talking about the moles of carbon dioxide released or evolved, it will be equals to the volume that is released divided by molar volume, converting this molar volume from liters to milliliters. So it's 25 into 10 raised to power 3, I guess. Okay, so herein we are going to get what? It is 10 raised to power minus 5. So these are the moles of carbon dioxide released. ठीक है, चलिए आगे बढ़ते हैं and let's talk about another thing. So if I just talk about the moles of carbon dioxide released, which is 10 raised to power minus 5 moles, so I can say the moles of sodium bicarbonate. Moles of sodium bicarbonate will be what? Okay, moles, therefore moles of sodium bicarbonate NaHCO3 will be actually also equals to 10 raised to power minus 5 moles by the stoichiometry of the reaction given over here. Hence, what's the mass now? Mass of sodium bicarbonate, mass of sodium bicarbonate, it will be what? It will be actually equals to the molar mass 84 grams per mole multiplied by the number of moles. Okay, so we are actually left with what? So it's equals to, if I just talk about, it's 0.84, I can write it like this, into 10 raised to power minus 3 grams. Okay, which means it is basically 0.84 milligrams I am going to talk about. Okay, fine. Well, if I just talk about the percentage by weight, if I just talk about the percentage by weight of sodium bicarbonate in the tablet, see, the mass of sodium bicarbonate is 0.84 and the mass, or you can say the weight of the tablet, it's 10 mg. Okay, multiplied by 100. So what we are going to result from here, it's basically 8.4%. So this is our right answer for the question asked for. Is it hard? No, it's actually not hard. Okay, Riddhi, today we are going to take the questions from all over physical chemistry, including 11th physical chemistry plus 12th physical chemistry. Okay, so the right answer of the question over here will be, it's 8.4%. That means what we are talking about, the percentage of sodium bicarbonate in each tablet will be 8.4%. So we are going to mark option number B as the right answer for the question asked for. Okay, I believe the things is now clear to you. Moving ahead, and let's talk about the second question in front of you. The second question says, and it's basically from atomic structure, the difference between the radii of third and fourth orbits. The difference between the radii of third and fourth orbits of Li2 positive is delta R1. The difference between the radii of third and fourth orbits of He positive is delta R2. We need to talk about the ratio of delta R1 to delta R2 is what? Okay. हाँ, might be possible sample आपने कोई mistake की हो calculation के अंदर. I agree to your point because the right answer is 8.4%. Okay, so over here Harsh Kumar says that ma'am, it's option number C, 3:2. Fine. So it's all okay. So Alta Mash is saying it's option number C. Okay. Yes, Mr. Dhruv Gautam, you can watch it. Ambuj is saying that it's basically option number A. Fine. So let's move ahead and talk about the calculation part over here. So these are the given things to us. These are the given things to us. Talking about the question again, it's the difference between the radii of third and fourth orbits of Li2 positive, which is delta R1, and the difference between the radii of third and fourth orbits of He positive is delta R2. We need to talk about the ratio of delta R1 to delta R2. Now we know one thing, the radius we know. Okay, so it's basically 0.529 into n square by z angstrom. Isn't it? Yes. So if I just talk about for Li2 positive, if I just talk about initially for Li2 positive, okay. So for Li2 positive, I'm actually going to talk about its radii, okay. So it's n is equals to 4 minus r Li2 positive, n is equals to 3 over here, which will be 0.529, okay. For Li2 positive, what's the value of Z? It's 3. It's basically n square, no. So n square, that means if I just talk about 4 square, it will become 16 minus 9. Okay, because we already know the formula of radii, 0.529 into n square by z, okay. So we are actually talking about the differences between the orbits third and fourth, which has been given to us as delta R1 for Li2 positive. Fine? Yes. Option number A is absolutely right. Talking about for He2 positive, if I just talk about for He positive, so it's R He positive, it's n equals to 4 minus R He positive, where n is equals to 3. So it is 0.529 by 2, and again it will be 16 minus 9, which is equals to delta R2. Okay. Talking about the ratios of delta R1 to delta R2. So when you will be actually taking the ratios of these two, what you are going to get is that 0.529 cancels out with 0.529, 16 minus 9 cancels out with 16 minus 9. We are actually straight away left with our answer, which is 2 by 3. Most of you have given the right answer. The easiest question. It's option number A, the right answer for the question asked for. So I believe it's been clear. It's clear. So without delaying much, since it was a very easy question, since it was a very easy question, let's move ahead and let's talk about question number 3 here. The question is again from atomic structure, and the question is of statement type. For the Balmer series in the spectrum of hydrogen atom, we have been given with the wave number, okay, which is equals to RH within bracket 1 upon n1 square minus 1 upon n2 square. The correct statement we need to talk about from 1 to 4th R. As wavelength decreases, the lines in the series converge. Converge means they are actually going to unite with each other. Talking about the second statement, the integer n1 is equal to 2. The line of longest wavelength corresponds to n2 equals to 3. The lines of the longest wavelength corresponds to n2 equals to 3. The ionization energy of the hydrogen can be calculated from the wave number of these lines. So please read the statement carefully and let me know the right answer for the question asked for over here. Just let me know. Okay, the line of the longest wavelength, okay, corresponds to n2 equals to 3. Okay, and we have been also given with the integer n1 is equals to 2, and the wavelength decreases, as wavelength decreases, the line in the series converge. They actually are going to be united. So what you are saying, talking about the options over here, these are the options in front of you, A, B, C and D. Which of these statements are the correct statement? Just let me know. So, come on. Let me actually clear each and everything over here, since we have been given with what? We have been given with the Balmer series. We have been given with the Balmer series. For Balmer series, if I just talk about the ground state, that means the value of N1, it is always equals to 2. So for Balmer series, the value of N, okay, is equals to 2, the ground state. Fine, okay. Well, Just have a look. For Lyman series, the ground state n equals to 1. For Paschen series, n equals to 3. For Brackett series, it's n equals to 4. For Pfund series, it's n equals to 5. For Humphrey series, it's basically n equals to 6. I believe the things are now clear. Moving ahead, and let's talk about one by one the statements given to us. Okay, I'll show you the question again. Here is the question, and I'll be discussing about the question one by one. Okay, well, first of all, let's discuss about the very first part. As wavelength decreases, the line in the series converge. Okay, so if I'm just talking about the wavelength decrement and the lines in the series converge, so I'll say it's the correct statement. It is the correct statement. See, as the n higher, if I just talk about the n higher value, okay, so this, as the n higher increases, the line starts to converge together. Okay, as the shell number, if I just talk about, or the orbit number, it starts to increase, the line starts to converge together. Increasing the n higher will actually indeed lead to an increase in the energy. Increase in the energy of what? Of photon that is released. And it will actually end up releasing the photons of shorter wavelength. So while we are actually moving above, that means when we are actually moving higher in the shells or in the orbits, what actually is going to happen, that we are going to receive the wavelength. Okay, I mean to say we are actually going to get the energy of the shortest wavelength. The energy released will be of the short wavelength. Okay, IIT Bombay, let me tell you, there the diagram has already been drawn. I'll make you understand from there also, so wait and watch. Okay, fine. So जैसे जैसे n की value बढ़ेगी, fine, what is going to happen, that energy of there will be actually increase in the energy of the photon that is released, having the shortest wavelength. Okay, now if I just combine these particular statements, what can I see, that that as the wavelength decreases, the length in the series converge. Okay, so when we are moving higher, that means when we are moving from n equals to 1, 2, 3 and 4, energy is increasing, and we know that energy is inversely proportional to wavelength. So as the energy is increasing, we are going to get the energy of the shortest wavelength, and that's absolutely fine. And hence, as the wavelength is decreasing, we are moving to a higher energy level. The lines in the series, they are going to converge, they are going to unite. So this is the correct statement. Talking about the second statement, the integer n1 is equals to 2. For Balmer series, it's fixed that the ground state n1 is equals to 2. Okay, for the Balmer series, or you can say it's a de-excitation series, or you can say the emission series, electrons get de-excited to n equals to 2, which means the n lower value. If I just talk about the n lower value, it is fixed, which is equals to 2. Okay, talking about the third statement, the lines of the longest wavelength corresponds to n2 equals to 3. See, as we are moving higher in energies, okay, so as the value of n is increasing, wavelength is decreasing, okay, and energy is increasing. Okay, so if n1 is equals to 2 and n2 is equals to 3, that means if the transition is taking place from n1 to n2 basically, okay, the lines of the longest wavelength corresponds to n2 equals to 3. Yes, we are moving from 2 to 3. Okay, over here the energy gap is less, but the wavelength will be long. Okay, so the line of longest wavelength corresponds to n2 equals to 3. It is actually, you can have a look, it's delta E is equals to hc by lambda. So when wavelength is increasing, energy is decreasing, and wavelength is actually increasing when we are moving from n1 is equals to 2 to n2 equals to 3. So 1, 2 and 3, these are the correct statement. Well, if I just talk about the ionization energy of hydrogen that can be calculated from the wave number of these lines, I'll say it's the incorrect statement. See, ionization energy, if I just talk about, it is equals to, the calculation part I'm going to talk about, well, it's the energy if I just talk about the ionization energy, it's the energy required to remove an electron from the isolated gaseous atom. Okay, so over here ionization energy calculation will be 13.6 Z square by N square. For hydrogen atom, Z is equals to 1. So we cannot actually calculate the ionization energy directly only by wave number. We actually require the transition state value also. So 1, 2 and 3 are the correct statement. It's the fourth which is not the correct statement. Okay. So Mr. IIT Bombay, as you were actually talking about the diagram, so here is the diagram in front of you. Okay. So when we are moving from N2, N1 is equals to 2 to N2 equals to 3, what we will see that over here the wavelength, if I just talk about the wavelength, see, when the electron is de-excited from N2 equals to 3 to N1 is equals to 1, okay, what we are going to get is that energy will be having a photon of lower energy, but its wavelength will be higher. Is it fine? So this is how we are going to explain to you each and everything. So our right answer will be option number A, which says that it's 1, 2 and 3. These three statements are the correct statement for the question asked for. I believe it's been clear to each and everyone. Yes? Okay. Moving ahead, and let's talk about the next question. Question number 4 here in front of you. चलिए क्वेश्चन नंबर 4 की अब हम बातचीत करते हैं क्वेश्चन नंबर 4 के बारे में, and it's the question given to you. You need to identify the pair in which the geometry of the species is T-shape and square pyramidals respectively. Okay. You need to identify the pair in which the geometry of the species is T-shape. Okay. And square pyramidal. Rather, I should say, you need to identify the pair in which the shape of the species is a T-shape and square pyramidal. Okay, so let me rectify it over here. It will be shape basically, because when we talk about the geometry actually includes the bond pairs as well as the lone pairs. It's the shape which only includes the bond pairs. Fine. So you need to rectify it over here. You need to identify the pair in which the shape of the species is T-shape, because if we are talking about T-shape is not a geometry basically. It's a shape. Square pyramidal is also a shape, not a geometry. Fine. So just let me know. Well, if I just talk about ICl2 negative and ICl5, okay, so all of you have said, not all of you, Abir is saying and Radheshamji is saying that it's option number C, ma'am, the right answer. Okay, moving ahead, we'll be discussing each and every part over here. So all of you are marking option number C the right answer, but Sampath Kumar says it's option number D. Okay, fine. Noted. Talking about ICl2 negative over here, if I just talk about ICl2 negative, fine. So if I talk about ICl2 negative, and this is the structure of ICl2 negative. See, one lone pair, the second lone pair, and this is the third lone pair. One Cl over here, the other Cl over here. Fine. So talking about the shape of this ICl2 negative, I'll say it's the linear shape. It's the linear shape I'm going to talk about. Okay, fine. And if I talk about the geometry of this ICl2 negative, I'll say it's trigonal bipyramidal geometry. Shape is linear. Talking about ICl5 now. Okay, so it's I, Cl over here, Cl over here, the third Cl over here, fourth Cl and the fifth Cl, okay, with a lone pair of electron. So I'll say its geometry is octahedral, but its shape is square pyramidal. Its shape is square pyramidal, and it's actually not fulfilling our condition given in the question. Okay, we want T-shape and square pyramidal, the pair which is T-shape and square pyramidal. So it's actually not fulfilling the conditions of the question. Moving ahead and talking about IO3 negative and IO2 F2 negative. So talking about IO3 negative, it's I, double bond O, O negative, and one lone pair of electron over here. Fine. So talking about its shape, if I just talk about its shape, it's trigonal pyramidal shape. It's trigonal pyramidal shape. Okay. And talking about the geometry, I'll say it's tetrahedral geometry. Talking about IO2 F2 negative, so it's I, F, F, okay, It's double bond O over here and a lone pair of electron here. So if I talk about its geometry, I'll say it's trigonal bipyramidal geometry, but yahan par if I just talk about the shape, I'll say it's seesaw shape. It's seesaw shape, okay? So it's also not fulfilling our condition. Fine. Any issues? No issues. चलिए moving ahead. आयोडीन पर 8 इलेक्ट्रॉन होते हैं क्या मैम? नहीं, आयोडीन पे देयर आर नो 8 इलेक्ट्रॉन्स, बट यहाँ जैसे आप बात कर रहे हैं इट्स एक्सपैंडिंग इट्स ऑक्टेट, यहाँ ये अपनी ऑक्टेट को एक्सपैंड कर रहा है, ध्यान रखिएगा इस बात का. फाइन, मूविंग अहेड एंड टॉकिंग अबाउट ClF3 एंड IO4 नेगेटिव. ओके, ClF3 की यहाँ बात कर लेते हैं. सो इट्स Cl, F, F and F over here and 2 lone pairs of electron over here. Fine. So we do have T shape over here. It's having the T shape and the geometry is trigonal bipyramidal geometry. Talking about IO4 negative, it's I, double bond O, double bond O, double bond O. It's O negative over here. Fine. So talking about its geometry and shape, I'll say it's basically tetrahedral. Cool? Fine? Okay. Yes, tell me. T shape and square planar you are saying. sp3d2. Fine. No, इसका जो हमारा hybridization आया है iodine का, it is sp3. आप calculate कर सकते हैं. IO4 negative का, it is sp3. Fine. And if it is sp3, तो geometry tetrahedral तो होगी. Talking about the last thing, it's XeOF2 and XeOF4. So it's XeOF2 double bond O over here, F over here and 2 lone pairs of electron over here. Fine. So, well, if I just talk about its shape, I'll say it's T shape having trigonal bipyramidal geometry. Talking about XeOF4, it's Xe double bond O. Fine. And it's F over here, F over here and F over here fluorine atom, and this is square pyramidal shape. This is having square pyramidal shape. Square pyramidal shape. Okay, fine. Any issues? So in a way we actually wanted, as Sampath Kumar was the first one to give me the right answer, T shape and square pyramidal. It's the actually option number D, the right answer for the question asked for. Clear? Done, done. Any issues to anyone? No issues. चलें आगे बढ़े. So why all of you are saying me about sp3d, sp3d2? See, hybridization, so I think you all know how to calculate through steric number, and steric number is basically half of what? The number of valence electrons of the central atom plus the number of monovalent atoms plus minus the charges. Okay, moving ahead and let's talk about question number 5 over here. Okay, Chakradhar. See, if I talk about hybridization, it's very easy to calculate through steric number. Okay, but you need to know one thing, that steric number is equals to half of the number of valence electrons of the central atom plus the number of monovalent atoms surrounding it plus minus the charges. So question number 5 is here, a very easy peasy lemon squeezy question, like dear ones. इसको तो आप चुटकियों में solve कर दोगे. Consider the van der Waals constants A and B for the following gases. The gases has been given to you: argon, neon, krypton and xenon. The values of A and B, these are the van der Waals constant given to us. Which gas is expected to have highest critical temperature? Which gas is actually expected to have a higher critical temperature? Now we know one thing, the formula of critical temperature. Tc is basically the critical temperature, which is equals to, which is directly proportional to A by B. If I just talk about its value, so Tc, critical temperature, is equals to 8A, okay, upon 27 Rb, which means this critical temperature is directly proportional to A by B ratio. Okay, yes, absolutely fine. So in which of the particular gas we are going to get this particular ratio higher? 1 by 1.3 by 3 by 2, 0.2 by 1.7, 5.1 by 1 and 4.1 by 5. It's actually appropriately been seen to us that from here we are going to get the ratio A by B as equals to 5.1, and I believe that none of the ratios will be greater than this particular value, all will be lesser than it. So yes, it was krypton. It was krypton. Yes, yes, absolutely right. All of you have given the right answer. It was an easy question. इस तरह के question भी JEE Mains पूछता है, ध्यान रखिएगा. Talking about question number 6, straight away moving ahead, and it's also a good and a easy peasy lemon squeezy question. Yeah. Fine. So given that carbon in the graphite state, okay, carbon, that means graphite, plus oxygen in the gaseous state giving us carbon dioxide, and for this reaction enthalpy, standard enthalpy of reaction is x kilojoules per mole. Fine. Talking about the next reaction, carbon, that means graphite plus half O2 in the gaseous state giving us CO in the gaseous state. So enthalpy of reaction, standard enthalpy of reaction is Y kilojoules per mole. CO plus half O2 giving us CO2, and enthalpy, standard enthalpy of reaction is Z kilojoules per mole. Based on the given thermochemical equations, we need to find out which one of the following algebraic relationships is correct. Fine, Ambuj, now I cannot do so because I have to lead many questions in this session, but we will be actually dealing with van der Waals equation very soon in our rapid revision series. Okay, so you need to wait there. So A says x equals to y plus z. B says z is equals to x plus y. C says, option C says y equals to twice of z minus x. D says it's x equals to y minus z. So what will be the right answer? Well, moving ahead, and let's talk about each and everything over here. We are given with the three equations to us, okay, and what we need to talk about the relationship between, the algebraic relationship between these three. Okay, see, we have been given with carbon in the graphite, this is graphite, plus oxygen in the gaseous state, which gives us carbon dioxide in the gaseous state. And for this, the enthalpy of reaction is equals to x kilojoules per mole. So mark it as first equation. Talking about the second, it's carbon in the graphite state plus half O2 in the gaseous state, okay, which gives us carbon monoxide in the gaseous state, and यहाँ पर standard enthalpy of reaction है y kilojoules per mole. ये हमारी second equation mark करते हैं. अब अगर मैं क्या करूँ, what should I do? बताएं आप मुझे, what should be done over here now? ठीक है, हमारे पास जो third equation थी, it was CO plus, it's in the gaseous state, plus half O2 in the gaseous state, okay, that is actually going to give us CO2 in the gaseous state. Fine. Now this first equation, if I just talk about the very first equation, okay, and if we add, and suppose this is our third, so if we add 2 plus 3, add 2 plus 3, okay, so adding 2 plus 3, what we are going to get? We are going to get carbon in the graphite state plus oxygen in the gaseous state giving us carbon monoxide. Fine. So what we can say over here, that x is equals to y plus z. This is the algebraic relationship. Relationship. So over here it's option number A, the right answer for this particular question asked for. Fine. So see, many of you said just because seeing this particular expression, that means this particular equation is something complicated compared to other ones. I'll say don't give the random answers. You need to be serious. It's the JEE session going on for your preparation. Okay. So just don't play anything over here. Just don't play randomly over here. You need to calculate the answer. It was a very easy question. Just by seeing the options, the one which is complicated, let's mark it. It's not gonna work. It's absolutely not gonna work. Okay. So it was option number A, x equals to y plus z. Fine. Okay, fine. Moving ahead and talking about the next question, question number 7 in front of you. Here we are. The values of Kp by Kc for the following reactions at 300 Kelvin are respectively. Fine. Hello Vikas, how are you? I am actually good. I believe that you are also good. So चलिए इसका आंसर बता दीजिए. The values of Kp by Kc for the following reactions. Okay. At 300 Kelvin hour. So Kp by Kc का we know the relationship. Kp by Kc का क्या relation होता है? Kp by Kc is equals to RT raised to power delta n. So majorly हमें delta n की value को find out करना है and then we'll be solving the things out. We have been given with one thing that the value of RT is equals to 24.62 decimeter cube ATM एटमॉस्फेयर मोल इनवर्स. बहुत इजी क्वेश्चन है. बस आपको इस पर्टिकुलर एक्सप्रेशन में जो मैंने अभी आपको दिया है इसमें वैल्यूज को सब्स्टिट्यूट करना है, नथिंग एल्स. चलिए अगर मैं Kp बाई Kc फॉर द फर्स्ट रिएक्शन की बात करती हूँ तो इस पर्टिकुलर फर्स्ट रिएक्शन के लिए डेल्टा एन की वैल्यू क्या होगी? डेल्टा एन क्या है? इट्स एक्चुअली डिफरेंस इन द टोटल नंबर ऑफ मोल्स ऑफ द प्रोडक्ट्स एंड द रिएक्टेंट्स दैट आर इन द गैसियस स्टेट. सो इट विल बी 2 minus 2 turns to 0. Okay. So for the first equation, Kp by Kc की value क्या होगी? It will be RT raised to power 0. Something raised to power 0 is 1. Okay. Well, if I talk about the second equation, इसके लिए delta n की value क्या है? Delta n की value इसके लिए है it's 2 minus 1 equals to 1. ठीक है. So यहाँ पर Kp by Kc will be equals to RT raised to power 1. And what's the value of RT? It's 24.62 decimeter cube ATM mole inverse. Talking about the third equation. So for this if I talk about delta n की value कितनी हो जाएगी? It will be 2 minus 4 which turns to minus 2. Which turns to what? It turns to minus 2. Okay. So यहाँ पर Kp by Kc will be actually equals to RT raised to power minus 2 which in turn is equals to 1 upon RT whole square which will be 1 upon 24.62 whole square. Okay. So when you will calculate this you are going to get the answer in a way 1.65 into 10 raised to power minus 3. 1.65 into 10 raised to power minus 6 और यहाँ पर जो अब हमारा units आएगा it will be decimeter raised to power minus 6, ATM raised to power minus 2 and it will be what? It was mole inverse. So when it, yeah, minus 6, minus 2 and it will be mole square. Kind of like this we are going to get the answer with us. Okay. Moving ahead and let's see the options over here. So it's 1, 24.62 and 1.65 into 10 raised to power minus 3. So it's option number B basically. Well, relationship I actually told you Kp equals to Kc RT raised to power delta Ng. Delta Ng मैंने आपको पहले ही बता दिया था. तो उसके हिसाब से देखा जाए नहीं, ऑप्शन A नहीं है आंसर. इट इज बेसिकली ऑप्शन नंबर B द राइट आंसर. ठीक है, ऑप्शंस मैंने आपको दिखा दिए थे. सो इट्स ऑप्शन नंबर बी जो हम कहेंगे बिल्कुल सही जवाब है इस पर्टिकुलर क्वेश्चन के लिए. चलिए मूव अहेड. बट बिफोर दैट अगर ये सेशन आप लोगों को पसंद आ रहा है प्लीज डू हिट द लाइक बटन. डोंट मिस दैट आउट. सब्सक्राइब द चैनल फॉर द फर्दर नोटिफिकेशंस एंड obviously the sessions are gonna be awesome in the coming near future. And yeah, do share this particular session with your friends so that they can also have a boost in their preparation. Talking about question number 8 now guys. Question number 8 की अगर हम यहाँ बात करें, an aqueous solution contains 0.1 molar H2S. ठीक है, 0.20 molar HCl. ये भी बात सही है. तो आगे क्या किया जाए? एक एक्वस सोल्यूशन है जो कंटेन करता है 0.1 मोलर H2S, 0.20 molar HCl. If the equilibrium constant for the formation of HS negative from H2S is 1 into 10 raised to power minus 7 and that of S2 negative from HS negative is 1.2 into 10 raised to power minus 13, तो हमें बताना है the concentration of this sulphide ion in aqueous solution is what? ठीक है. So what we are given with over here, the concentrations of H2S and HCl. We have also been given with the equilibrium constant for the formation of HS negative as well as S2 negative. that has been given to us. हमें concentration of S2 negative बतानी है, तो बताएं कैसे इस पर्टिकुलर क्वेश्चन को सॉल्व किया जाएगा। देखिए अगर मैं बात कर रही हूँ H2S की सबसे पहले, ठीक है, सो आई एम गोइंग टू गेट HS नेगेटिव प्लस H पॉजिटिव। यहाँ पर Ka1 की वैल्यू कितनी दी हुई है, 1 इंटू 10⁻⁻7। अब HS नेगेटिव जो है, HS नेगेटिव होगा यहाँ पर, it is going to dissociate into S2 negative plus H positive। तो यहाँ पर Ka2 की हमें क्या वैल्यू दी हुई है, 1.2 इंटू 10⁻⁻13 हमें वैल्यू दी हुई है, ठीक है। अब क्या किया जाए, what should we do, हमें क्या बताना है, what we need to tell the concentration of S2 negative। तो अगर इन दोनों को मैं अगर ऐड कर देती हूँ, I am going to get it is H2S which is going to give me S2 negative, which is going to give me S2 negative, fine, it's H2S then HS plus H positive, okay, then HS giving us S2 negative plus H positive. Now H2S that is actually giving me S2 negative okay, we have been actually adding it up, okay, fine, any issues, no issues, twice of H positive I am going to get, twice of H positive I am going to get. So K will be equals to Ka1 into Ka2 since I added it. So it will be, it's 1.2 into 10⁻20, 10⁻⁻20, that is what I am going to get. यहाँ तक चीजें क्लियर हो गई हैं, यहाँ तक क्लियर हो गई हैं, तो बताइए अब अगर मैं कॉन्सेंट्रेशन S2 नेगेटिव की पता करना चाहती हूँ, ठीक है, तो वी नो दैट K इक्वल्स टू concentration of S2 negative, fine, concentration of H positive raised to power 2 upon the concentration of H2S, ठीक है। हमें S2 negative आयन की concentration पता करनी है, it will be equals to K into H2S divided by H positive की concentration raised to power 2, यही करना था पता हमें। सब्स्टिट्यूट कर दीजिए वैल्यू को, K की वैल्यू क्या है, 1.2 into 10⁻⁻20। What is the concentration of H2S? It is 0.10. What is the concentration of H positive ion? Concentration क्या है H positive ion का? It is 0.2, ठीक है, it's 0.2। तो इसको हम कैसे लिख सकते हैं, it's 0.1 we have been given with, तो क्या मैं इसको 10⁻⁻1 लिख सकती हूँ, yes, और क्या मैं इसको 2 into 10⁻, यहाँ देखिए it's 0.1 we have been given with and then it's 2 into 10⁻⁻1 again and whole square, kind of like this. Is it clear? इसको जब आप solve करेंगे then we are going to get the concentration of S2 negative is equals to 3 into 10⁻⁻, what, 2.2 होगा, नहीं, 3 into 10⁻⁻20 मोलर होगा इसका आंसर। आप देख लीजिएगा, इसका आंसर यही आएगा। इट विल बी, ये जो नीचे वाला वैल्यू है 2 into 10⁻⁻1, अर्का सेज नो, व्हाई नो, यस अर्का आप कैलकुलेट कीजिए, आपका यही आंसर आएगा। 2 into 10⁻⁻1 का होल स्क्वायर क्या होगा, 4 into 10⁻⁻2 एंड देन यू सॉल्व इट, यू आर गोइंग टू गेट द आंसर एज 3 into 10⁻⁻2 मोलर। तो उस हिसाब से हमारा जो आंसर आएगा इट्स विल बी ऑप्शन नंबर ए द राइट आंसर फॉर द क्वेश्चन आस्क्ड फॉर, ठीक है। कैलकुलेट कीजिए, उसके बाद यहाँ पर जवाब दीजिएगा, ठीक है, कि बिना कैलकुलेशन के तो यार यू आर नॉट गोना डू एनीथिंग, ठीक है। ओके चलिए, हेयरइन वी आर टॉकिंग अबाउट, वी विल बी टॉकिंग अबाउट क्वेश्चन नंबर 9। क्वेश्चन नंबर 9 देख लीजिए, बहुत ही अच्छा उम्दा क्वेश्चन है, बहुत ही अच्छा उम्दा क्वेश्चन है। द रिडॉक्स रिएक्शन अमंग द फॉलोइंग इज, हमें रिडॉक्स रिएक्शन के बारे में बताना है। Reaction of H2SO4 with NaOH, formation of ozone from atmospheric oxygen in the presence of sunlight, combination of dinitrogen with dioxygen at 2000 Kelvin, and the reaction of H2O6Cl3 with AgNO3। मैं दोबारा से आपको क्वेश्चन दिखा देती हूँ, क्वेश्चन को बहुत अच्छे से पढ़ लीजिए, फटाफट से बताइएगा कि इसमें से कौन सा रिडॉक्स रिएक्शन है हमारा, ठीक है, तो चलिए हेयर इन इफ आई जस्ट टॉक अबाउट द न्यूट्रलाइजेशन रिएक्शन विच इज टेकिंग प्लेस बिटवीन NaOH एंड H2SO4. तो देखिए NaOH और H2SO4 जो कि एक बेस है और एक एसिड है, वी आर गोइंग टू गेट द सॉल्ट एंड वाटर. तो ये जो हमारा पहला जो हमारा स्टेटमेंट था, इट वाज फॉर द न्यूट्रलाइजेशन रिएक्शन. टॉकिंग अबाउट द सेकेंड स्टेटमेंट, जहां पर हमने क्या फॉर्म किया, जहां वी आर टॉकिंग अबाउट द फॉर्मेशन ऑफ ओजोन. ओके, वी आर टॉकिंग अबाउट द फॉर्मेशन ऑफ ओजोन. ठीक है, तो ओजोन इन स्ट्रेटोस्फीयर है यहाँ पर. ठीक है, सो इट्स अ नॉन रिडॉक्स रिएक्शन. जो पहला रिएक्शन था इट वाज न्यूट्रलाइजेशन. जो बी स्टेटमेंट थी इट वाज फॉर द ओजोन फॉर्मेशन इन स्ट्रेटोस्फीयर. अब जो हमारा थर्ड रिएक्शन है कॉम्बिनेशन ऑफ N2 एंड O2, उसको आप देखिए. इट्स N2 विच इज इन द जीरो ऑक्सीडेशन स्टेट एंड इट्स ऑक्सीजन विच इज इन द जीरो ऑक्सीडेशन स्टेट. लेकिन NO के अंदर ऑक्सीजन के पास वी आर हैविंग -2 ऑक्सीडेशन स्टेट एंड नाइट्रोजन पे वी आर हैविंग +2 ऑक्सीडेशन स्टेट. सो ऑक्सीजन जो नाइट्रोजन था, we are seeing the change in oxidation state of nitrogen from 0 to +2. that means यहाँ oxidation हो रहा है. And we are seeing the change in the oxidation state of oxygen from 0 to -2. That means यहाँ reduction हो रहा है. If that is the case, that means simultaneously यहाँ पर क्या हो रहा है, ऑक्सीडेशन एंड रिडक्शन दोनों ही हो रहा है. So I'll say it's the redox reaction. ठीक है, चाहे अब कोई कुछ भी कहे, ये रिडॉक्स रिएक्शन है, इसको कोई बदल नहीं सकता. टॉकिंग अबाउट द लास्ट वन वेयर इन वी वर टॉकिंग अबाउट अ कोऑर्डिनेशन कंपाउंड गिवन टू अस, wherein the Cl3 was out of the coordination sphere, reacting with AgNO3, we are going to get 3 moles of AgCl and hence the corresponding complex. Okay, तो यहाँ पर precipitation reaction मैं आपको कहूँगी. This is precipitation reaction, not the redox reaction. तो उसके हिसाब से जो हमसे पूछा गया, the redox reaction among the following is, it's option number C, the right answer for the question asked for. Hope that's actually clear to you. That's actually clear to you. ठीक है, चलिए herein we are going to talk about now without delaying much because पहले वाला question बहुत ही easy peasy lemon squeezy था. हम बात करेंगे question number 10 की and it's in front of you. Again I'll say it's a good question. Read it and let me know the answer of this question. मैं थोड़ा सा यहाँ अपने गले को आराम दे लेती हूँ. आप इस question को पढ़िए. After 30 seconds I'm going to read this for you. क्वेश्चन को आराम से देखिएगा, पढ़िएगा, सोचिएगा, विचारिएगा, फिर इसका आंसर दीजिएगा. फिर इसका आंसर आपको मुझे देना पड़ेगा. ठीक है, कम ऑन डियर वंस, कम ऑन. इजी पीजी लेमन स्क्वीजी. सुधांशु, यस इट इज एब्सोल्युटली इजी पीजी लेमन स्क्वीजी. ओके, बताएं. जस्ट लेट मी नो द आंसर ऑफ दिस पर्टिकुलर क्वेश्चन. हाँ जी, वेटिंग फॉर यू गाइज. ठीक है. Hello Mr. Indian, how are you? Welcome to the class. बड़े लेट आए यार, but still we are left with 10 more questions to go. In this particular session, I am going to discuss, what I am going to discuss, a total of 20 questions with you. We are on the 10th questions. We need to actually speed up our pace. Okay, fine. We need to actually go ahead with our pace. So Shamina says, ma'am, it's option number B. Okay, Shamina, you are saying that, ma'am, it's option number B. Let's talk about. Yeah, I'm good. Ayush saying. तो चलिए, a crystal is made up of metal ions. एक crystal है, it is made up of metal ions M1 and M2. Fine. And oxide ions. Okay, oxide ions, they form a CCP lattice, cubic closed packing lattice structure. The cation M1, it occupies 50% of the octahedral voids, and the cation M2, it occupies 12.5% of the tetrahedral voids of the oxide lattice. The oxidation number of M1 and M2 we need to talk about respectively. Harsh says that it's option number D. Well, Harsh, it will be noted in my diary, in my mind, that yeah, you are the first one to give me the right answer to this particular question. Moving ahead, and चलिए बात करते हैं इस particular question के solution के बारे में. Crystal क्या बना हुआ है, किससे बना हुआ है? Metal ions M1, M2 and oxide ions से बना हुआ है. Metal ion M1 ऑक्यूपाई करता है 50% ऑफ द ऑक्टाहेड्रल वॉइड एंड मेटल आयन 2 ऑक्यूपाई करता है 12.5% ऑफ द टेट्राहेड्रल वॉइड्स. तो अगर मैं बात करती हूँ अबाउट द CCP लैटिस, ओके, सो इन द CCP लैटिस if I just talk about the oxide ions in the CCP lattice of oxide ions, effective number of O2 negative ions will be what? Basically CCP के बारे में जब हम बात करते हैं तो हम FCC के बारे में भी चर्चा कर ही लेते हैं, है कि नहीं है? तो यहाँ पर अगर मैं बात करती हूँ in the CCP lattice of oxide ions, in the CCP lattice of oxide ions, इफेक्टिव नंबर ऑफ ऑक्साइड आयंस कितने हैं? इफेक्टिव नंबर ऑफ ऑक्साइड आयंस कितने हो गए भाई? सो कहाँ कहाँ प्रेजेंट होंगे? एट द फेस सेंटर्स, ओके, एंड एज एट द कॉर्नर्स. तो कॉर्नर्स का इट्स 1/8 into 8. If I talk about the face centers, it's half into 6. So a total of 4 I'll just say. A total of 4 I'm going to say. ठीक है. अब अगर मैं बात करती हूँ the positions of octahedral void in CCP lattice. So octahedral voids का जो position होता है, it is basically what? Edge centers plus body center. Edge center plus body center. Edge center कितने होते हैं? 12 edge centers होते हैं. उनका क्या contribution होता है to the lattice? 1/4. So 1/4 into 12 plus body center 1, which leads to 4. Talking about tetrahedral voids, they are twice of octahedral voids. 2 into 4 equals to 8. अब चीजें sorted out हो जाएंगी. Well, if I just talk about M1, if I just talk about, okay, so number of M1 metal atoms, number of M1 metal atoms की अगर मैं यहाँ पर बात करती हूँ या metal ions की मैं यहाँ बात करती हूँ, so it will be 50% of the octahedral void. So 50/100 into 4 I'm going to talk about. So 50/100 into 4 is equals to 2. Number of M2 metal ions. Number of M2 metal ions की मैं अगर यहाँ बात करती हूँ, metal atoms की मैं यहाँ अगर बात करूँ, so it's basically 12.5/100 of 8, which leads to what? It leads to, if I just talk about this particular thing, it's 12.5/100 into 8, which is equals to 1. ठीक है. तो अगर मैं फॉर्मूला ऑफ द कंपाउंड की यहाँ बात करती हूँ, इफ आई जस्ट टॉक अबाउट द फॉर्मूला ऑफ द कंपाउंड, चलिए फॉर्मूला की बात करते हैं. फॉर्मूला क्या है कंपाउंड का? फिर हमारा अब फॉर्मूला होगा, इट इज M1 ऑफ द 2, ओके, M2 ऑफ द 1 एंड इट्स ऑक्सीजन ऑफ द 4. चलिए ये वाली भी बात हमने कर ली है. अब अगर मैं चार्जेस की यहाँ बात करती हूँ, इफ आई जस्ट टॉक अबाउट द चार्जेस, चलिए चार्जेस की भी हम यहाँ बात कर लेते हैं, चर्चा कर लेते हैं चार्जेस की भी. चलिए चार्जेस की बात करते हैं. इट्स M1 विद अस, इट्स M2 विद अस एंड इट्स ऑक्सीजन विद अस. ठीक है. तो ये है 2, ये है 1 एंड ये है 4. ठीक है. सपोज द चार्ज ऑन M1, अगर मैं चार्ज M1 की बात करूँ, लेट इट बी x, तो वो कितना हो जाएगा? 2x हो जाएगा. 1 का अगर मैं बात करूँ, चार्ज ऑन M2 इज y, लेकिन चार्ज ऑन ऑक्साइड आयन कितना होता है? -2. ठीक है. तो यहाँ मैं क्या कहूंगी? इट विल बी 4 into 2, इट इज इक्वल्स टू 8. ठीक है. तो हमारे पास वी डू हैव -8 चार्ज on oxide and we need to neutralize our particular compound. In order to do so, अगर मैं ये कहती हूँ it's 2x plus y equals to 8 we have. ठीक है. तो ये particular x and y किस particular charges से they are going to fulfill our answer. ठीक है. तो it's 2x plus y equals to 8. We were having 2x plus y equals to 8. So if x is 2 and y is 4, we are going to get the answer as 8. तो यहाँ पर हिट एंड ट्रायल आपको देखना है. ये 3 और C, आई मीन टू से A और C ऑप्शन तो आउट ऑफ द रेस है. इट वॉज बिटवीन B एंड D, 4 and 2, लेकिन अगर आप X की जगह 4 रखेंगे, इट इज नॉट गोइंग टू सेटिस्फाई आर दिस पर्टिकुलर इक्वेशन. सो इट्स ओनली ऑप्शन नंबर D. समझ में आया? इट वॉज वेरी इजी क्वेश्चन. ऑप्शन नंबर D वैसे सबने बोला, ऑप्शन नंबर D वैसे सबने बोला सही है. ठीक है. तो ये भी समझ में आ गया जो हमने यहाँ किया. Did you get the things we have done over here? Fine. Moving ahead and talking about question number 11. अब हम बात करते हैं question number 11 की. चलिए question number 11 हमने लिया है solution से. Good question to be discussed upon. Molecules of benzoic acid C6H5COOH, they are going to dimerize in benzene. ठीक है. W gram of the acid. Okay, which acid? This benzoic acid इट गॉट डिजोल्व्ड इन 30 ग्राम्स ऑफ बेंजीन. बेंजीन क्या है हमारा? सॉल्वेंट है. इट शोज अ डिप्रेशन इन फ्रीजिंग पॉइंट इक्वल टू 2 केल्विन. इफ द परसेंटेज एसोसिएशन ऑफ द एसिड टू फॉर्म अ डाइमर in the solution is 80%, then we need to talk about the weight W. W के बारे में हमें बात करनी है, इसके बारे में हमें बात करनी है. KF हमें दिया हुआ है, ओके फाइन, फाइन, which is 5 Kelvin kg per mole. मोलर मास हमें बेंजोइक एसिड का दे रखा है. इट्स मोलर डिप्रेशन कांस्टेंट बिन गिवन टू अस. तो चलिए बात करते हैं. ऑप्शंस आपको दिए हुए हैं. Well, what have been given to us? The mass of the benzene, the solvent have been given to us. Delta TF depression in freezing point भी हमें दिया हुआ है, percentage association भी दिया हुआ है, molar depression constant भी दिया हुआ है, mass हमें बताना है C6H5COOH का. Delta TF की वैल्यू क्या होती है? It's IKFM. और I क्या है? It is the number of moles after dissociation divided by number of moles before dissociation. Easy peasy lemon squeezy, absolutely right. आप बिल्कुल सही कह रहे हैं. तो देखिए हमारा यहाँ पर C6H5COOH जो था, it got dimerized. C6H5COOH and this is whole 2. तो at time t equals to 0 पे मैं क्या कहूंगी? Let the number of moles be 1 and this 0. ठीक है. And at time t equals to t पे मैं क्या कहूंगी? इसके मोल्स कितने रहेंगे? अगर अल्फा इज द एसोसिएशन, डिग्री ऑफ एसोसिएशन, अगर अल्फा डिग्री ऑफ एसोसिएशन है तो टाइम t इक्वल्स टू t पे क्या होगा? इट विल बी 1 माइनस 2 अल्फा मैं कर सकती हूँ, और यहाँ पर इट विल बी 2 अल्फा बाय 2 हो जाएगा. दैट मीन्स अल्फा आई एम गोइंग टू गेट द नंबर ऑफ मोल्स आई एम गोइंग टू टॉक अबाउट. सो हमारे मोल्स एट इक्विलिब्रियम कितने हो गए? मोल्स एट इक्विलिब्रियम हमारे कितने हो गए? इट इज 1 माइनस 2 अल्फा प्लस अल्फा विच इज इक्वल्स टू 1 माइनस अल्फा. ठीक है. अब हमें यहाँ पर परसेंटेज ऑफ एसोसिएशन दिया हुआ है. दैट मीन्स 2 अल्फा इज इक्वल्स टू 0.8. 80% था, 80% था, तो मैं क्या 80% का मतलब हो गया 80 by 100 विच इज 0.8. फाइन. सो 2 अल्फा क्या हो गया? ये क्या है हमारा? डिग्री ऑफ एसोसिएशन की मैं यहाँ बात कर रही हूँ. 2 अल्फा इज 0.8, तो अल्फा की वैल्यू क्या हो जाएगी? 0.4 हो जाएगा. तो अगर मैं टोटल मोल्स एट इक्विलिब्रियम की बात करूँ, इफ आई जस्ट टॉक अबाउट टोटल मोल्स एट इक्विलिब्रियम, टोटल मोल्स एट इक्विलिब्रियम की अगर मैं बात करूं, सो इट विल बी 1 माइनस अल्फा विच इज इक्वल्स टू 1 माइनस 0.4 टर्न्स टू 0.6. ठीक है, क्लियर है. तो I क्या होगा? वेंट ऑफ फैक्टर I क्या होगा? I विल बी इक्वल्स टू द नंबर ऑफ पार्टिकल्स आफ्टर association, number of particles after association by number of particles before association which is equals to 0.6. now I की वैल्यू हमें अब पता चल चुकी है. I की वैल्यू अब हमें पता चल चुकी है. So I think you have noted down all these things. So let me just rub these things and let me do the calculation part over here. Delta TF क्या होता है? Delta TF is equals to I into KF into ME. हम पहले ही बात कर चुके हैं. I की वैल्यू 0.6 है हमारे पास, KF की वैल्यू 5 है हमारे पास. अगर मैं यहाँ मोलैलिटी की बात करती हूँ, इट्स द नंबर ऑफ मोल्स ऑफ सोल्यूट इन kg ऑफ सॉल्वेंट, इन kg ऑफ सॉल्वेंट. ठीक है. बेंजोइक एसिड के वेट के बारे में हमें यहाँ पर बात करनी है. वी हैव बीन गिवन विद द मॉलिक्यूलर वेट ऑफ बेंजोइक एसिड. तो मोल्स कितने हो जाएंगे? W by 122 एंड यहाँ पर सॉल्वेंट का वेट इन kg, सो इट्स 30 ग्राम्स. चेंजिंग इट इनटू kg, तो वो 1000 से डिवाइड करना होगा, वो 1000 ऊपर मल्टीप्लीकेशन में चला जाएगा. है फाइन. एंड डेल्टा TF हमें क्या दिया हुआ है? द वैल्यू ऑफ डेल्टा TF given to us is 2. given to us is as 2. तो यहाँ से आपको एक तरह से इस पर्टिकुलर इक्वेशन को रीअरेंज करना है एंड यू नीड टू गेट द आंसर. सो W will be equals to what? 5 into 0.6. W will be equals to, wait a minute, let me just talk about each and everything over here. W क्या होगा? डेल्टा TF. Okay, W will be 2 into 30 into 122 divided by 0.6 into 5 into 1000. इसको कैलकुलेट करेंगे, आंसर आएगा 2.4 ग्राम्स. समझ में आया? 2.4 ग्राम्स इज आवर आंसर. सो बताएं, अबीर, हर्ष, आयुष्मान, अंबुज, देवेंद्र, चलिए सब बताएं, इसका आंसर आपका यही आया, इट्स 2.4 ग्राम्स दैट यू आर गोइंग टू गेट, यस। सो उसके हिसाब से देखा जाए इट्स ऑप्शन नंबर बी द राइट आंसर फॉर द क्वेश्चन आस्क्ड फॉर। ठीक है, डन डन डन। चलिए भाई बताए इफ द थिंग्स हैव बीन क्लियर। आयुष्मान आप तो कह रहे थे इट्स इजी पीजी लेमन स्क्वीजी क्वेश्चन, ओके, इज इट सो? चलिए let's see, we'll talk about the same. And again there is a question from solutions only. The freezing point of a diluted milk sample is found to be minus 0.2 degrees Celsius, while it should have been minus 0.5 degrees Celsius for the pure milk. ठीक है, हाउ मच वाटर हैज बिन एडेड टू प्योर मिल्क टू मेक द डाइल्यूटेड सैंपल। यार ये तो जो हमारे एक तरह से आजकल तो हमें पैकेट वाला दूध मिलता है, ओके फाइन, बट उससे पहले यू कैन जस्ट आस्क, और या अभी भी ये चलता है, there is the milkman comes to our house and delivers the milk, and obviously that particular milk is not at all pure. उसमें कुछ ना कुछ मिलावट होती ही होती है, क्यों भाई, होती है ना? yes, it's there. so freezing point होना चाहिए था minus 0.5 डिग्री सेल्सियस, लेकिन है minus 0.2 डिग्री सेल्सियस। तो हमें बताना है कितना पानी डाला गया in the pure milk to make it a diluted sample। चलिए, तो यहाँ पर हम हमेशा हम यहाँ क्या बात कर रहे हैं, आई मीन टू से हम यहाँ बात करने वाले हैं डिप्रेशन इन फ्रीजिंग पॉइंट डेल्टा टी एफ क्या है, I इंटू के एफ इंटू एम। क्लियर, फाइन। तो यहाँ हमें सारी वैल्यूज दी हुई हैं। तो अगर मैं बात करना चाहूँ फ्रीजिंग पॉइंट, आई मीन टू से अगर मैं बात करना चाहूँ, सबसे पहले देखिए डेल्टा टी एफ डैश की बात करते हैं। सो डेल्टा टी एफ डैश में क्या करना चाह रही हूँ यहाँ पर, इट इज इक्वल्स टू 0.2 degree Celsius. Okay, that means I want to say depression freezing point of the diluted sample. Okay, it's for the diluted sample I'm actually going to talk about, diluted sample. ठीक है, डेल्टा टी एफ क्या होता है, इट्स टी नॉट माइनस टी एस। टी नॉट क्या होता है, फ्रीजिंग पॉइंट ऑफ द सॉल्वेंट, एंड टी एस क्या होता है, फ्रीजिंग पॉइंट ऑफ द सोल्यूशन। तो फ्रीजिंग पॉइंट ऑफ द सोल्यूशन ही है हमारा माइनस 0.2 डिग्री सेल्सियस, एंड सॉल्वेंट की बात करें वाटर तो 0 डिग्री सेल्सियस करके कर सकते हैं। सो इट्स 0 माइनस माइनस ऑफ 0.2, तो डेल्टा टी एफ डैश दैट मीन्स डिप्रेशन इन फ्रीजिंग पॉइंट अगर मैं बात करती हूँ फॉर डाइल्यूटेड सैंपल इट्स 0.2 डिग्री सेल्सियस। सिमिलरली अगर मैं बात करूँ डेल्टा टी एफ की फॉर द प्योर मिल्क, ओके, अगर मैं बात करती हूँ प्योर मिल्क के बारे में, इफ आई टॉक अबाउट प्योर मिल्क, सो डेल्टा टी एफ उसके लिए क्या हो जाएगा, 0.5 डिग्री सेल्सियस हो जाएगा। ठीक है, अब हमें ये, अगर मैं ये करती हूँ डेल्टा टी एफ अपॉन डेल्टा टी एफ डैश, ओके, सो इट इज बेसिकली के एफ इंटू एम, आई से आई कैंसिल हो जाएगा, वेंट ऑफ फैक्टर से वेंट ऑफ फैक्टर कैंसिल, अपॉन इट्स के एफ इंटू एम। यहाँ मैं कर सकती हूँ एम डैश की, मैं यहाँ बात कर रही हूँ, के एफ से के एफ भी कैंसिल कीजिए, इट्स एम अपॉन एम डैश की यहाँ पर हम बात कर लेते हैं। सो एम अपॉन एम डैश की अगर मैं बात करूँ तो डेल्टा टी एफ की वैल्यू क्या है, इट्स 0.5, एंड डेल्टा टी एफ डैश की क्या है, 0.2 है ये हमारे पास में। ठीक है, ये m क्या है, मोलालिटी है। तो एक तरह से अगर मैं मोलालिटी का फॉर्मूला भी आपको बताती हूँ, सो हेयर वी आर मोलालिटी के अंदर वी आर गोइंग टू टॉक अबाउट द मोलालिटी की अगर बात करती हूँ, नंबर ऑफ मोल्स ऑफ अ सोल्यूट इन अ kg ऑफ अ सॉल्वेंट, मोल्स क्या हो जाएंगे, वेट अपॉन मोलर मास। तो वही मैं बात यहाँ पर करने वाली हूँ आपसे। ठीक है, सो यहाँ देखिए इट्स m अपॉन m डैश, ओके, विच टर्न्स टू 0.5 बाय 0.2। तो यहाँ से हमें क्या एक्सप्रेशन मिलेगा, 0.5 बाय 0.2 जब मैं करूंगी, हमें क्या बताना है, हमें what we need to talk about, how much water has been added to pure milk to make the sample, make the dilute sample. So यहाँ से it will be W1 dash upon W1 आ जाएगा यहाँ से। ठीक है, सो यहाँ से इसको जब हमने कैलकुलेट किया, इट विल बी 5/2, इट विल बी 5/2 देयर। तो मैं एक तरह से कह सकती हूँ कि 2 कप्स ऑफ द प्योर मिल्क, ये 2 कप्स ऑफ द प्योर मिल्क हो गया हमारा, 2 कप्स ऑफ द प्योर मिल्क, ओके, मिक्स्ड विद 3 कप्स ऑफ द वाटर, तभी तो W1-5 बना। W1-5 कैसे बना, जब हमने 2 कप प्योर मिल्क में 3 कप वाटर मिला दिए तब। तो ओवरऑल वी कैन से 5 कप्स ऑफ द डाइल्यूटेड सैंपल वी आर हैविंग। हाँ जी आयुष्मान, क्लियर हुआ? बैकअप, हर्ष, क्लियर होगा ये वाली चीज जो मैं आपसे कहना चाहती हूँ? तो यहाँ आप देख लीजिए व्हाट एक्चुअली आई वांट टू क्लियर, KF इंटू एम अपॉन KF इंटू एम डैश, यहाँ आप वैल्यू सब्स्टिट्यूट कर दीजिए, you need to substitute the values over here and you are going to get its W1 dash upon W1। तो एक तरह से 2 कप प्योर मिल्क में 3 कप हम पानी मिला रहे हैं to get the 5 cups of the diluted sample, ठीक है? तो it's basically option number 8, 3 cups of water and 2 cups of the pure milk। Done, done, done. Any doubt to anyone? No doubt. So here we are on the question number 13 in front of you. चलिए question number 13 की बात करते हैं। Question number 13 क्या कह रहा है? A flask contains, okay, mixture of compounds A and B, fine. Both compounds decompose. Both of the compounds, they are going to decompose by first order kinetics. By first order kinetics. The half lives of A and B are 300 seconds, okay, and 180 seconds respectively. If the concentrations of A and B are equal initially, okay, A और B के initially concentrations equal हैं, then the time required for the concentrations of A to be 4 times that of B in second is what? It's a very good question. एक फ्लास्क हमें दिया हुआ है, a flask contains a mixture of compounds A and B, both compounds they decompose by first order kinetics, half life भी हमें दी हुई है A और B की 300 and 180 seconds। अगर concentration A और B की initially equal है तो हमें बताना है time required for the concentration जब A की concentration will be 4 times of that of the B concentration। ये रहा given thing to us। तो एक तरह से फर्स्ट ऑर्डर काइनेटिक्स की अगर मैं बात करती हूँ, एंड इट्स वी नो दैट इट्स A इक्वल्स टू A नॉट E रेज टू पावर माइनस KT, ठीक है? व्हाट्स द वैल्यू ऑफ K? इट इज इक्वल्स टू ln2 अपॉन T हाफ, ये मैं लिख सकती हूँ, ओके, ये भी हमें पता है। नाउ व्हाट वी नीड टू डू इज, ठीक है, वी हैव बीन गिवन दैट वी नीड टू टॉक अबाउट द टाइम व्हेन AT इज इक्वल्स टू 4 टाइम्स ऑफ BT। Initially AI is equals to BI, ठीक है? तो we know that it's A equals to 4 times of B. For this particular condition we need to talk about the time. ये कब होगा, किस particular time पे होगा? Okay, what is A? A naught E raised to power minus KT, and it's 4 times of what B we are talking about. So it's B naught E raised to power minus KT. Substitute the values of K over here to the respective half lives also. So it's A naught E raised to power minus it's ln2 upon T half of A, which is 300, fine, minus K, wait a minute, minus K, okay, E raised to power this and it's T and it's 4 into B naught E raised to power minus, wait a minute, minus, let me take it outside, it's ln2 upon 180 into T. So this T value we need to calculate out. ये T value हमें calculate out करनी है। Initially, अगर मैं initial चीज की बात करूं, so हमारा A naught is equals to B naught है, तो ये equal हो गए हैं। So it's E raised to power, what we are actually having with us, minus ln2 upon 300 of the T equals to 4 E raised to power minus ln2 upon 180 into T, ठीक है? तो अब हम इसको ऐसे लिख सकते हैं, 4 is equals to E raised to power, 4 is equals to E raised to power and it's ln2 upon 180 minus no, wait a minute, 4 will be then equals to what? Wait a minute, yeah, I was doing correct. 4 is equals to E raised to power and it is ln2 upon 180 minus ln2 upon 300 into T. Can we write it like this? Yes, we can actually write it like this. अब आगे क्या करना है? It will be ln4 equals to ln2 upon 180 माइनस ln2 अपॉन 300, हम ऐसे इसको अब लिख सकते हैं। ln2 की वैल्यू क्या है? ln2 की वैल्यू क्या है भाई, ये बताइए। ln2 की वैल्यू है 0.693, ठीक है? और ln4 की वैल्यू क्या हो जाएगी? 1.0 1.38. Okay, so एक तरह से we are moving over here, it's 1.38 divided by 0.693, and over here it is equals to 1 upon 180 minus 1 upon 300, okay, into T. So it will be then equals to 2. So 2 is equals to, now 2 is actually equals to what? It's 300 minus 180 upon 180 into 300 into T. बस यहाँ से आपको rearrange करना है ये चीजें. You need to now rearrange it. So while you are rearranging it, your T will be equals to 2 into 180 into 300 divided by 120. Okay, so it becomes equals to 900 seconds. Okay, according to it, we'll be having the answer as option number D, the right answer for the question asked for. Hope that's actually clear. It was all dependent on the calculation. So you need to actually focus on the calculation, but otherwise the things will be abruptly go wrong. Okay, the things will abruptly go wrong. So it's basically option number D to be talked upon, the right answer for the question asked for. Guys, how's the Josh? Let me know about your Josh, your energy, in which particular state you are. Are you in the excited state or in the ground state? Just let me know. Fine. Okay. चलिए यार शॉर्टकट कैसे बताऊं इसका, कैलकुलेशन करनी तो पड़ेगी, we need to do the calculations. Okay, चलिए क्वेश्चन नंबर 14 की बात करते हैं, and it's also a good question. For a reaction, consider the plot of ln k versus 1 by t. A question based upon surface chemistry, wherein we are going to talk about Freundlich adsorption. No. Again, it's the question of chemical kinetics. Again, it's the question of chemical kinetics. ln k versus 1 by t given in the figure. If the rate constant of the reaction at 400 Kelvin is 10 raised to power minus 5 second inverse, then the rate constant at 500 Kelvin is what? So it's ln k versus 1 by t. Okay. Okay, fine. तो यहाँ स्लोप हमें दिया हुआ है -4606 केल्विन. ऑप्शंस हमें बताने हैं A, B, C and D. ठीक है. These are the options in front of you. चलिए, we will be solving this out. See, we know that at two different temperatures, if we actually want to calculate out the, you can say the rate constant value given with the activation energy thing also, we'll be actually using this formula. Okay, it's basically the Arrhenius equation we are taking into account. So it's log K2 by K1 equals to EA upon 2.303 R, 1 upon T1 minus 1 upon T2. This is we are going to talk about. Well, if I just talk about the slope given to us, okay, so it's ln K initially equals to ln A minus EA upon RT we have been given with, okay. Now slope is equals to what? Slope is EA upon RT. Slope is equals to what? Minus EA upon RT, that is equals to minus 4606. This cancels with this. So the value of, if I just talk about the value basically of EA upon RT is equals to 4606. ठीक है, ये slope की value आ गई है. Now we know one thing. What we know about one thing, that it's ln K2 by K1, okay, equals to EA upon R, equals to EA upon R. It's ln, एक minute, we did a mistake. Okay, the slope is minus EA upon R. Slope is minus EA upon R. So EA upon R we are having, and then it will be T2 minus T1 upon T1 into T2. Substitute the values and get the results. EA upon R is 4606. What is T2? It's 500 minus 400, it's 100, divided by 500 into 400. Solve it, you'll get the answer basically. So over here 4606, it's 100 upon 20,000, so you are going to get the answer as 2.303 for this. Okay, so it's ln K2 by K1 is equals to 2.303. Now if I just change this ln K2 by K1 to log, so it is log K2 by K1. Okay, so it's, if I talk about ln, what is ln? It's 2.303 of log basically, log to the base 10. So it was 2.303 over here. I'll take this 2.303 in denominator. So it's 2.303. The value we have got this divided by 2.303. So log to the base 10 K2 by K1 will be equals to 1 over here. Okay. So K2 by K1 will be what? If log to the base 10 K2 by K1 is 1, so K2 by K1 will be equals to 10. Okay. Now we want to talk about K2. K2 will be equals to 10 into K1. And what is K1 given to us? 10 raised to power minus 5. So your answer will be 10 raised to power minus 4 second inverse, the value of K2. So here we are with option number D, the right answer for the question asked for. हाँ जी, सही बताया, सही समझाया. आगे बढ़ते हैं और बात करते हैं क्वेश्चन नंबर 15 की विदाउट एनी डिले. तो चलिए, अभी के कोई बच्चा मुझे कह रहा था कि इलेक्ट्रोकेमिस्ट्री का क्वेश्चन मैम, तो ये देख लीजिए, हियर वी आर विद द इलेक्ट्रोकेमिस्ट्री क्वेश्चन. आपको पसंद आएगा, काफी अच्छा और इजी क्वेश्चन है. गिवन स्टैंडर्ड इलेक्ट्रोड पोटेंशियल, given standard electrode potential, Fe3 positive in the aqueous state plus thrice of electrons giving us Fe in the solid state, Fe2 positive in the aqueous state plus 2 electrons giving us Fe in the solid state. For them we are having the corresponding standard electrode potentials value. The value of standard electrode potential for this particular reaction, is what? Fe3 positive plus electron to Fe2 positive. तो बताएं इसका जवाब क्या होगा? What will be the answer of this particular question? Here we are and let's talk about this particular thing. चलिए, what we are having actually with us? Yes. तो यहाँ पर मैं बता दूं, it's Fe plus 3 electrons giving us what? Fe. And even for this is equals to 0, minus I will say, even for this is equals to minus 0.036 volt. Okay. Talking about its Fe plus 2 electrons giving us what? Fe again. And E2, if I just talk about E2 naught, it is given to us as, just let me know, it's basically minus 0.439 volt. 439 volt. चलिए, तो अब हमें क्या करना है? If I just talk about the equations over here, if I just subtract the equations from here, okay, we need to have our one equation Fe3 positive to Fe2 positive. So if I just subtract these equations, it's Fe plus 3, okay, Fe plus 3 plus 1 electron giving me Fe plus 2, okay, and E3 naught for this will be what we need to calculate out. We know one thing, that delta G naught is equals to minus NFE naught. Isn't it? So delta G3 naught is equals to delta G1 naught minus delta G2 naught. ठीक है? Yeah, see, I'm actually solving the questions for you guys. So do cooperate and let's go ahead with these things. It's very easy now. So it's minus NFE3 naught equals to minus, what should I say? It's N3. It's N1 FE1 naught minus N2 FE2 naught. You have to just solve this now. When you will do it, you will get the answer E3 naught equals to, E3 naught is equals to thrice of E1 naught minus twice of E2 naught over here. Fine? Yes. This is what we are going to get. ये हमें मिलेगा minus of minus. Yes, it will be. Here we are actually having the things with us. Fine? Okay, okay, fine, no issues. यहाँ हमें चीजें समझ में आ गई है. So E3 naught is equals to thrice of E1 naught minus twice of E2 naught. Values को यहाँ substitute कीजिए. It's 3 into minus 0.036, okay, minus 2 into minus 0.439. And when you solve this, E3 value will be 0.77 volt. ये हमारा आंसर आएगा. E3 नॉट की ये वैल्यू आएगी. उसके हिसाब से देखा जाए ऑप्शन नंबर सी इज द राइट आंसर. ऑप्शन सी राइट आंसर है. चलिए, टॉकिंग अबाउट नाउ क्वेश्चन 16, यहां तक समझ में आ गया है. एंड ओवर हियर इट्स अगेन द क्वेश्चन. ऑफ सरफेस केमिस्ट्री, ये भी सरफेस केमिस्ट्री का क्वेश्चन है। द फ्लॉक्युलेशन वैल्यू, हमें यहाँ पर फ्लॉक्युलेशन वैल्यू के बारे में हम बात कर रहे हैं। फ्लॉक्युलेशन वैल्यू ऑफ HCl फॉर आर्सेनिक सल्फाइड सोल इज 30 मिलीमोल्स पर लीटर। अगर H2SO4 यूज हुआ है फॉर द फ्लॉक्युलेशन ऑफ आर्सेनिक सल्फाइड, द अमाउंट इन ग्राम्स ऑफ H2SO4, ओके, in 250 ml required for the above purpose is what? Above purpose is what? Just let me know. Hello Mr. Study with Age, good afternoon. तो हमें बताना है कि 250 ml के लिए कितने ग्राम्स H2SO4 का रिक्वायरमेंट है फॉर इट्स फ्लॉक्युलेशन बेसिकली, ठीक है, तो ये हमें बताना है। अगर मैं फ्लॉक्युलेटिंग वैल्यू की यहाँ बात करती हूँ, इट इज डिफाइंड एज व्हाट, मिलीमोल्स पर लीटर ऑफ कोगुलेटिंग एजेंट रिक्वायर्ड टू कोगुलेट अ कोलॉइडल सोल। AS2S3 जो है, इट्स बेसिकली व्हाट, इट्स अ नेगेटिव चार्ज सोल, सो H पॉजिटिव फ्रॉम HCl इज गोइंग टू ब्रिंग द प्रेसिपिटेशन ओवर हियर, ठीक है। तो यहाँ मैं आपको एक बात बताना चाहती हूँ, फॉर 1 liter we are actually requiring 30 millimoles of HCl for flocculation. तो 250 ml के लिए how much millimoles of HCl will be required? It will be straight away 30/4 millimoles, 30/4 millimoles हमें चाहिए HCl के। अब HCl की अगर मैं बात करती हूँ, we are having one H positive ion and one Cl negative ion. When H2SO4 get dissociated, we will be having twice of H positive ion. तो यहाँ 1 mole of H2SO4 से हमें 2 moles H positive ion के मिल रहे हैं, और यहाँ 1 mole of HCl से 1 mole H positive ion के मिल रहे हैं। तो 250 ml पर्टिकुलर सोल्यूशन को फ्लॉक्युलेट करने के लिए बेसिकली वी रिक्वायर 30/4 मिलीमोल्स ऑफ HCl। तो इससे इसका अगर मैं हाफ कर दूंगी, विल बी रिक्वायरिंग इट फॉर H2SO4, बिकॉज एक H2SO4 का मोल हमें 2 H पॉजिटिव आयंस दे रहा है, ठीक है। तो एक तरह से यहाँ पर जो फ्लॉक्युलेशन होगा फ्रॉम H2SO4, इट विल बी हाफ द मिलीमोल्स ऑफ HCl रिक्वायर्ड, ठीक है, क्लियर है। 2 HCl के मोल से 2 H पॉजिटिव मिलेंगे, लेकिन हमें 1 H2SO4 के मोल से 2 H पॉजिटिव मिल रहे हैं। तो यहां मैं स्ट्रेट अवे कहूंगी, देयरफॉर फॉर 250 ml we actually require 30/4 into 2 millimoles of H2SO4। ये मिलीमोल्स हमें मिल गए। अब इसका हमें वेट कैलकुलेट करना है, बस और कुछ नहीं करना है। तो वेट ऑफ H2SO4 कितना हो जाएगा? वेट ऑफ H2SO4 कितना हो जाएगा? इट विल बी 30/4 into 2, ये मिलीमोल्स है, इसको मोल्स में करेंगे इंटू 10⁻³ मल्टीप्लाइड बाय 98 ग्राम्स पर मोल द मोलर मास ऑफ H2SO4। इसे जब आप कैलकुलेट करेंगे आपका आंसर आएगा 0.3675 ग्राम्स, which approximates to 0.37 grams। ये आपका सही आंसर है, थैंक यू सो मच अंबुज फॉर द कॉम्प्लीमेंट। तो यहाँ पर दिस इज आवर राइट आंसर फॉर दिस इंटीजर टाइप ऑफ द क्वेश्चन। डन, क्लियर है ये वाली चीज। चलिए लेट्स मूव ahead to the next question. It's question number 17 I'm going to talk about. Question number 17 की बात करते हैं, and this question is from surface chemistry. This particular question is from surface chemistry. For Freundlich adsorption isotherm, एक प्लॉट हमें दिया हुआ है for log x/m. x/m क्या है? It's the extent of adsorption that is taking place. So log x/m and log p gives a straight line. The intercept and slope for the line has been also given to us, 0.4771 and 2. Okay, the mass of the gas adsorbed हमें बताना है per gram of the adsorbent if the initial pressure is 0.04 atm. It is equals to dash into 10⁻⁻4 grams. Easy question है ये। फ्रेंडलिच एड्सॉर्प्शन आइसोथर्म के बारे में हम यहाँ चर्चा कर रहे हैं, जहां पर जो स्लोप है 1/n, इसकी भी वैल्यू हमें दी हुई है और इंटरसेप्ट की वैल्यू भी हमें दी हुई है। इंटरसेप्ट क्या है? 0.4771, स्लोप क्या है? 2 हमें दिया हुआ है। सो वी नीड टू टॉक अबाउट द वैल्यू ऑफ m, गैस एड्सॉर्ब्ड इन गैस। Okay. Hello, Mr. Aman. No, for this answer will not be 6. You need to calculate again. Okay. So, Mr. Putin, just also let me know the answer of this question. It's very easy to solve the question for. तो यहाँ पर simply, yes, I got the things. हमें पता है it's x by m equals to k p raised to power 1 by n. We know about this. 1 by n का value हमें पता है. Okay, हमें ये पता है, ये सारी चीजें हमें पता. तो क्या करें, क्या किया जाए यहाँ पर? देखिए, it's x by m equals to k p raised to power 1 by n. अगर मैं log ले लेती हूँ, log x by m equals to log k plus 1 by n log p. ये हो जाएगा. क्लियर है? क्लियर है ये वाली चीज? तो इससे हमें क्या पता चल रहा है? log k का वैल्यू, log k अगर मैं बात करना चाहूँ, इट्स बेसिकली 0.4771. ओके, फाइन. एक तरह से यहाँ हमें log k का वैल्यू दिया हुआ है जो है 0.4771. तो k की वैल्यू आ जाएगी. k की वैल्यू क्या होगी? It will be 10 raised to power 0.4771. अब log k 0.4771 कब होता है? कब होता है? It's the value of log 3. तो k की वैल्यू हमारी आ गई यहाँ पर 3. k की वैल्यू आ गई 3. 1 by n का वैल्यू हमें पता है, it is 2. सब्स्टिट्यूट कीजिए यहाँ पर x by m के अंदर. x by m के अंदर we need to actually substitute our value. ठीक है? So x by m क्या हो जाएगा? 3p square हो जाएगा. ठीक है. अब p की वैल्यू क्या दी हुई है? 0.04 दिया हुआ है. 0.04 दिया हुआ है. ठीक है. What we are going to talk about, it's 3 into 0.04 whole square. We'll be calculating it out. ठीक है. So the mass of gas absorbed per gram of the adsorbent is basically will be equals to 48 into 10 raised to power minus 4 grams. ये होगा हमारा आंसर. Mass of the gas absorbed होगा हमारा ये particular answer. So I believe ये particular question समझ में आ गया आपको. ठीक है, क्लियर है? तो ये हमारा आंसर होने वाला है. 48 into 10 raised to power minus 4. Mass of the gas absorbed per gram of adsorbent. अगर initial pressure 0.04 atm है. बताएं, is it clear? The things are clear to you? Okay, done. कोई doubt? अमन, इसका आंसर 6 नहीं है, इसका आंसर 48 है. ठीक है? Because x by m क्या होता है? It's the extent of adsorption that is actually taking place on adsorbent. तो यहाँ से हमारा x by m का जो वैल्यू आया वो आया 48 into 10 raised to minus 4. तो यही हमारा मास होगा. Talking about question number 18, a question which was electrochemistry based question. ठीक है. We need to consider a cell Zn to Zn2 positive, 1 molar concentration, Fe3 positive to Fe2 positive aqueous. The fraction of total iron present as Fe3 positive ion at the cell potential of 1.500 volt is x into 10 raised to power minus 2. The value of x is what we need to talk about. We have been given with the standard electrode potentials, standard reduction potentials of E Fe3 positive to Fe2 positive and E Zn2 positive to Zn. ठीक है, done. Fine. तो यहाँ देखिए, it's very simple to talk about. This is what we are going to use. Okay? Yeah. कुछ previous year questions हैं जो बहुत ज़्यादा important हैं, वही I am actually talking about here. तो यहाँ देखिए, it is, अगर मैं reaction लिखूँ, it's Zn giving us Zn2 positive plus 2 electron, and then we have, it's twice of Fe plus 3, which is giving actually, wait a minute, it's 2 electrons, Fe3 positive giving us 2 electrons plus it's twice of Fe2 positive. This is what we will be actually dealing with. अगर इनको मैं add कर देती हूँ, Zn plus twice of Fe plus 3, okay, no, if I just want to subtract them, wait a minute, Zn plus twice of Fe3 positive, okay, wait a minute, I need to do something over here, I did a mistake. It's twice of Fe3 positive plus 2 electrons, that is going to be giving me twice of Fe plus 2. So it will be Zn plus twice of Fe3 positive, which is going to give me Zn2 positive plus twice of Fe plus 2. This is what we are actually having. फाइन. सो यहाँ अगर मैं E नॉट ऑफ द सेल की यहाँ बात करूँ, सो इट्स E ऑफ द कैथोड माइनस E ऑफ द एनोड. तो E ऑफ द कैथोड की अगर मैं यहाँ पर बात करती हूँ, सो इट्स E नॉट Fe 3 positive to Fe2 positive minus E naught Zn2 positive to Zn. So we will be actually getting the answer as 0.77 minus of minus 0.76, which turns to 1.53. We need to substitute each and everything over here. It's 1.5 given to us, okay, which is equals to 1.53 minus 0.059 by 2. Okay, it is by 2 and it's log to the base 10, and it will be Fe plus 2 upon Fe plus 3 whole square. The concentration of Zn2 positive is 1, so I am ignoring it. Fine, done, 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 done. Okay, so from here what we are going to get the answer, it's log Fe plus 2 by Fe plus 3. Okay, you'll get the answer as 0.03 upon 0.06. This is 0.06 you will get. You need to solve it, and this is the expression at the end you are going to get, which is equals to half then. Moving ahead, if I just talk about its Fe plus 2 upon Fe plus 3, which will be giving me as log, no, it will be giving me as 10 raised to power half, which is equals to root 10. यहाँ तक समझ में आ गया? यहाँ तक समझ में आ गया? ये आपको सॉल्व करना है. ये एक्सप्रेशन जब आप सॉल्व करेंगे, इसके बाद स्ट्रेट अवे यू आर गोइंग टू गेट दिस. log Fe2 positive upon Fe3 positive is equals to 0.03 by 0.06, which is equals to 1 by 2. This is what you are going to get. अगर मैं log को remove कर दूं, तो it's 10 raised to power half I am going to get and root of the 10. हमें क्या बताना है? Fraction of total iron present as Fe3 positive. We need to actually talk about the value of this. We need to talk about the value of this. हमें ये बताना है. Fraction of total iron present as Fe3 positive at the cell potential. So इसके लिए what we are going to do? Add 1 both the sides. So plus 1 over here and plus 1 over here. So what we are going to get, it's Fe plus 3, Fe plus 3 plus Fe plus 2, which will be equals to what? Root 10 plus 1. Now इसका रिवर्स कर दीजिए. इसका रिवर्स करेंगे तो इट्स Fe plus 3 upon Fe plus 3 plus Fe plus 2, ये हमें मिल जाएगा, which is equals to 1 upon root 10 plus 1. root 10 की वैल्यू होती है 3.16. So it will be 3.16 plus 1, which tends to 1 upon 4.16. तो यहाँ से जो आपको आंसर मिलेगा, it will be 24 into 10 raised to power minus 2. 24 into 10 raised to power minus 2. ठीक है, ये हो गया. This is your answer, and hence your answer will be 24, the right answer for the question asked for. We are now left with 2 more questions. Going ahead and talking about question number 19. बहुत अच्छा question है ये. Coordination chemistry का है. कितने बच्चों को ये question आता है? Just raise your hands. Give me the thumbs up over here. Complexes Ml5 of metals, nickel and iron have ideal square pyramidal and trigonal bipyramidal geometries. Okay. The sum of the 90 degree, 120 degree and 180 degree LML angles in the two complexes is what? ठीक है, ये बहुत easy question है. Ml5 के बारे में बात कर रहे हैं, जहाँ metals निकल और आयरन है. स्क्वायर पिरामिडल और ट्राइगोनल बायपिरामिडल ज्योमेट्रीज बताई हुई हैं. हमें सम बताना है 90 डिग्री, 120 डिग्री एंड 180 डिग्री का फॉर बोथ द टू कॉम्प्लेक्सेस. चलिए, अगर मैं ट्राइगोनल बायपिरामिडल की बात करती हूँ, ट्राइगोनल बायपिरामिडल की मैं यहाँ बात कर रही हूँ. लेट्स काउंट फॉर द नंबर ऑफ 180 डिग्री एंगल्स. कितने 180 डिग्री एंगल्स हैं? वी डू हैव ओनली 180 डिग्री एंगल, 1. कितने 120 डिग्री एंगल्स हैं? ठीक है, अगर 120 डिग्री एंगल के बारे में बात करें तो आप देखिए L, L एंड L, इसको लीजिए. दिस 120 डिग्री एंगल, ये 120 डिग्री एंगल है. ओके, एंड दिस इज ऑल्सो 120 डिग्री एंगल. तो कितने 120 डिग्री एंगल हो गए? 3. अब अगर मैं बात करती हूँ 90 डिग्री एंगल की, तो देखिए यहाँ पर नाउ जस्ट हैव ए लुक. ये हमारा मेटल है, ये L और ये L। अगर यहाँ पर L लगा दिया जाए ऊपर से, तो ये देखिए ये 90 डिग्री बनाएगा, ये भी इसके साथ 90 डिग्री बनाएगा। ठीक है, क्लियर हो रही है बातें। और ये जो लीगेंड L है और ये वाला जो लीगेंड L है, ये भी 90 डिग्री बनाएगा। तो ऊपर हमें मिले 3 90 डिग्री एंगल। अगर मैं दूसरा L लगा दूं तो ऐसे ही 3 90 डिग्री एंगल हमें नीचे से मिल जाएंगे। तो 90 डिग्री के कितने एंगल्स हो गए हमारे पास? इन टोटल 6 हो गए हैं। टोटल कितने हो गए हमारे पास? इनका सम कितना हो गया? 10 फॉर ट्राइगोनल बायपिरामिडल। फॉर ट्राइगोनल बायपिरामिडल we have 180 degree angle, 3 120 degree angles, 6 90 degree angles. तो in total we are having 10। नहीं रोहन, गलत है ये आंसर। अब अगर मैं बात करती हूँ स्क्वायर पिरामिडल के बारे में, स्क्वायर पिरामिडल के बारे में देखिए, तो पहले मैं एक बार ये स्क्वायर बना लूं यहाँ पर। ठीक है, फाइन, ओके। तो ये देखिए, दिस इज 90 डिग्री एंगल, ये 90 डिग्री एंगल है, ये 90 डिग्री एंगल है, ये 90 डिग्री एंगल है। ठीक है, ये मैंने 4 आपको 90 डिग्री एंगल अभी बताए हैं। अभी हमारे पास 90 डिग्री कितने एंगल है? 4 और भी आएंगे, वेट अ मिनट। ठीक है, इसको एक बार आप देख लीजिए, ये 4 90 डिग्री के एंगल हैं। ओके, अब अगर मैं बात करूं 180 डिग्री एंगल की, ये 180 डिग्री एंगल है, ये वाला और ये वाला। तो एक तरह से 180 डिग्री एंगल कितने हो गए हमारे पास? 2 हो गए हैं। यहाँ पर कोई भी एंगल 120 डिग्री का नहीं होगा। नाउ अगर मैं यहाँ एक L यहाँ और लगा देती हूँ, L यहाँ लगा देती हूँ, ओके, वन मोर लीगेंड अगर मैं यहाँ प्लेस कर देती हूँ, तो देखिए दिस इज ऑफ 90 डिग्री एंगल, दिस वन इज ऑल्सो 90 डिग्री एंगल। ये वाला लीगेंड इस वाले लीगेंड के साथ में 90 डिग्री एंगल बनाएगा और ये वाला लीगेंड इस वाले लीगेंड के साथ में 90 डिग्री एंगल बनाएगा। मोर 4 90 degree angles. So in total we are having 8 90 degree angles and 180 degree angles, a total of 10. तो अगर मैं इन दोनों ट्राइगोनल बायपिरामिडल का और स्क्वायर पिरामिडल के एंगल्स का सम करूं, 180, 120 and 90, so in total I will be having 20. So 20 है इसका आंसर। Okay, हर्ष कुमार, it's 20. Very good, absolutely fine. Good one, 20 है। Let's move ahead and talk about the last question of the session. ये है हमारा last question, easy peasy lemon squeezy होगा ये। And here we are, NaClO3 is used even in spacecrafts to produce oxygen. NaClO3 plus Fe giving us O2, FeO and NaCl. The daily consumption of pure oxygen by a person, the daily consumption of pure oxygen by a person is 492 liters at 1 atm 300 Kelvin. How much amount of NaCl3 in grams is required to produce oxygen for the daily consumption of person at 1 atm and 300 Kelvin? हमें बताना है कितना अमाउंट NaClO3 का इन ग्राम्स इज रिक्वायर्ड टू प्रोड्यूस ऑक्सीजन फॉर डेली कंजप्शन ऑफ अ पर्सन एट 1 atm एंड 300 केल्विन। आर की वैल्यू हमें दी हुई है, वी नीड टू टॉक अबाउट दिस सेम। अगर मैं रिएक्शन की स्टोकियोमेट्री से के हिसाब से जाऊं, इट इज 1 मोल्स ऑफ NaClO3, 1 मोल ऑफ NaClO3 गिविंग मी 1 मोल ऑफ ऑक्सीजन। इस बात का ध्यान रखिएगा। दैट मीन्स मोल्स ऑफ NaClO3 इज इक्वल्स टू द मोल्स ऑफ ऑक्सीजन। Moles of NaClO3 is equals to the moles of oxygen। बिल्कुल सही बात, बिल्कुल सही मयंक, आपने बिल्कुल सही जवाब दिया। इट इज 2130 ग्राम्स, एब्सोल्युटली राइट। ठीक है, तो मोल्स में अगर ऑक्सीजन के बताना चाहूंगी, यहाँ पर मोल्स ऑफ ऑक्सीजन कितने हो जाएंगे? इट विल बी PV/RT का फॉर्मूला लगा देते हैं। सो यहाँ पर प्रेशर कितना दिया हुआ है? 1, वॉल्यूम कितनी है? 492 एंड वैल्यू ऑफ आर क्या है? 0.082 इंटू टेम्परेचर टी क्या है हमें गिवन? 300 हमें गिवन है। तो यहाँ से जो नंबर ऑफ मोल्स आएंगे, कितने नंबर ऑफ मोल्स आएंगे जब आप इसको कैलकुलेट करेंगे? इट इज गोइंग टू कम आउट एज 20 मोल्स। 20 मोल्स आ जाएंगे। अगर 20 मोल्स आए, दैट मीन्स मोल्स ऑफ NaClO3 कितना हो गया? मोल्स ऑफ NaClO3 कितने हो गए? 20 मोल्स हो गए हैं, 20 मोल्स हो गए हैं। सो मास ऑफ NaClO3 कितना हो जाएगा? मास ऑफ NaClO3 कितना हो जाएगा? NaClO3 कितना हो जाएगा? इट विल बी 20 मोल्स, इट विल बी 20 मोल्स। ओके, और NaCl3 का मोलर मास क्या है? इट इज 106.5 ग्राम पर मोल। तो ये कैंसिल आउट हुआ इससे। अब हम आपको इसको पर्टिकुलरली कैलकुलेट करना है। सो वी आर गोइंग टू गेट 2130 ग्राम्स। सो दिस इज द आंसर ऑफ द क्वेश्चन आस्क्ड फॉर। ठीक है, सो मयंक आप बिल्कुल सही थे, इट इज 2130 ग्राम्स द राइट आंसर फॉर द क्वेश्चन, कि हमें 2130 ग्राम्स ऑफ NaCl3 रिक्वायर्ड है to produce oxygen for daily consumption of the person at 180 m and 300 Kelvin. So my dear ones, this was all from my side. Today we have discussed 20 questions from physical chemistry, the important 20 questions I have discussed. Hope you have liked this session very much, and I believe that there is no doubt left over here. All the things have been clear. Well, the upcoming session is of the paper analysis with the experts. It's about the physics class I'm actually talking about. Sharp at 8 p.m. you need to be present. Okay. Well, my dear ones, thank you so much. We'll be meeting you soon tomorrow at the same timings, 3 p.m. with the organic session. Okay, organic sessions, that too most important questions of organic chemistry I'm going to take over here. So be there sharp at 3 p.m. We'll be meeting soon. Bye bye, take care, and yeah, be in your good health.